Right, let's talk a little bit more about solving linear equations. So these are going to be pretty similar to what we saw last time, but there's going to be a couple special cases, especially ones with fractions that get a little bit tricky. So let's go ahead and just talk about the steps that you should take in general to solve an equation. And then we'll jump into just a bunch of examples. So first thing you always want to do, and this is something we saw last time, is that you always want to make sure that you simplify completely first. And that's just so you don't have to keep moving things around and end up with a bunch more steps than you need. And so first thing we want to do is remember always distribute first or clear parentheses. Second thing you want to do is, and this is one thing we'll see today that we haven't seen before, is clear any fractions or decimals. And so this is because sometimes you'll have equations that have a bunch of fractions in them or a bunch of decimals. And instead of having to do all of the arithmetic with the fractions or decimals, we can go ahead and just get rid of them. Once you've done that, we can go ahead and combine like terms. And so this is all just the simplifying step. Second thing we want to do is get the variables on one side, or the variable terms. Constants on the other. Remember, constants are those terms that don't have a variable in them. All right, third thing we want to do is get the variable alone and positive. And so remember, we don't want to end up with any negative x's. We always want a positive x at the end. And then that's our final step for solving. The last one is just to check the solution. All right, so let's go ahead and jump into some examples. So first one here is pretty similar to what we saw last time. Negative 5p plus 4 equals 19. And so if we take a look at this, both sides are already simplified. We can't combine any like terms or distribute. And so now we want to get the variable terms on one side, numbers on the other, constants on the other. We only have one variable term, so let's go ahead and leave that on the left. We'll move this 4 over to the right. It's addition, so we do the opposite and we subtract. So these 4's cancel, and then we have negative 5p equals 15. And now we want to get rid of this negative 5, and always think about how the number is joined to the variable or the variable term. So negative 5 is being multiplied by p, so we're going to go ahead and do the opposite and divide by negative 5. What we do to one side, we have to do to the other. The negative 5's cancel, and so we're left with p equals negative 3. So this one, if you were going to go ahead and check this, always make sure you're plugging this back into the very first equation before you did any simplifying. All right, let's go ahead and try another one. Go ahead and just put this one on the side here. So let's go ahead and try 5 minus 8k equals 2k minus 5. So now first thing we want to do is get our variable terms on one side, constants on the other. Doesn't matter which way you do it. In general, I'll just try to put the variables on the left for when we get to inequalities in a few sections. Those are always easier to have on the left. So first thing I'll do here is I'll go ahead and subtract this 2k And if you're moving a variable term, you have to always add or subtract the entire term. We can't get rid of this 2 by itself yet because we still have another term over here. And remember, we can only combine it with like terms, so we're not combining it with this 5. So this 5 stays here. -8 minus 2 is -10k. These guys cancel, and we're left with a -5. Variable terms are on the left, so we'll move the constants to the right. So we have a +5 here. So to get rid of this, we need to subtract 5 from both sides. We're left with a -10k equals -5 minus 5 is -10. They're not opposite, so they don't cancel. And now we want to get rid of this -10. They're joined by multiplication, so let's divide by -10. And so these guys cancel, and we're left with k equals +1. All right, let's go ahead and try. Put one more here. 6x plus 7 equals -8 plus 3x. So again, everything is simplified, so let's start moving things around. I'll again move all the variables to the left side first. So I'll subtract 3x. And so 6x minus 3x is 3x. Bring down this +7. And then on the right, we're just left with -8. Variables are on the left. Let's move this constant to the right. So opposite of addition is subtraction. So subtract 7 from both sides. Those cancel. And we're left with 3x equals -8 minus 7 is -15. And then finally 3 times x, so we divide by 3. And then 3's cancel, and we're left with x equals -5. So those first examples are similar to the ones we did last time. We'll do a few more of these. Number 4, let's go ahead and do 7 parentheses p minus 2 plus p equals 2p plus 4. So now notice how the right side is simplified, but the left side is not. So first thing we have to do here is clear the parentheses by distributing. So 7 times p is 7p. 7 times -2 is -14. Plus p equals 2p plus 4. Now we want to go ahead and finish simplifying, so we'll combine like terms here. So 7p plus 1 more p gives us 8p. Still have this -14 equals 2p plus 4. Now that everything's completely simplified, it looks just like one of the examples we just did. So let's go ahead and get the variable terms on one side, numbers on the other. So this, I'll move all of them to the left again. So +2p, so we have to subtract 2p. And so 8p minus 2p is 6p minus 14 equals +4. Move the constants to the right, so we'll add 14. We're left with 6p equals 4 plus 14 is 18. And then we'll go ahead and divide both sides by 6. And so we get p equals 3. All right, let's go ahead and try one more of these. All right, so let's go ahead and do 5x minus parentheses x plus 9 equals x minus 4. So let's go ahead and clear the parentheses first. So remember this minus sign here, there's an imaginary, well, not imaginary, but there's a 1 here that we just don't write. So let's go ahead and distribute that -1 in, and we'll leave that 5x in front. -1 times x is -1x, or negative x. -1 times 9 is -9. Make sure you're distributing a -1, not just a 1. Equals x minus 4. And then we'll go ahead and combine like terms. So 5x minus 1x is 4x. Minus 9 equals x minus 4. Get all the variables on one side. So let's go ahead and move this x over to the left. It's a positive x, so we'll subtract x. And 4x minus 1x is 3x. Minus 9 equals -4. Move the constants to the right, so let's add 9. And so these cancel, and we get 3x equals -4 plus 9 is 5. And then we'll go ahead and divide both sides by 3. These cancel, and we get x equals 5/3. So sometimes you will end up with fractions for answers, and that's perfectly fine. The check might be a little bit messier than others, but it's still possible. We just have to take this 5/3 and plug it in here and do a little bit of simplifying with fractions. All right. Number 6. We've got 2 times x minus 6 equals 2x minus 12. And so now this first one is going to be one of our special cases. So let's go ahead and take a look at what this one looks like. So first thing we have to do here is go ahead and simplify. So let's distribute this 2. So 2 times x is 2x. 2 times -6 is -12 equals 2x minus 12. And so if you notice at this point, both sides of the equation are the same. So this is your first indicator that this is one of our special cases, but we can go ahead and keep going through until we're left with just one term on each side. So we'll do the same as we did last time. I'll move all the variables to the left. So let's go ahead and subtract 2x from both sides. So these cancel on the left, and they cancel on the right. Since we have other terms here, we don't have to put a 0. We'll just leave -12 equals -12. So anytime you have this at the end where you end up with a number equals the same number, this means that we can plug in any number we want into the left side and it'll equal the right side. That's because both sides, when we simplified, were exactly the same. So no matter what, we're always going to get a true statement. And so this one is all real numbers, which just says we can plug in any number we want, even if it's a fraction or a decimal, and still get a true statement. All right, and let's go ahead and look at our second special case. So number 7. Let's go ahead and do -4x plus 12 equals 3 minus 4 parentheses x minus 3. And so for this one, the left side is already simplified, so I'm going to bring that one down. But the right side is not. So on the right side, we need to go ahead and distribute first. Remember, you can't combine this 3 and 4 yet because subtraction comes after multiplication. So let's distribute in this -4. bring down that 3 in the front. Negative 4 times x is negative 4x. Negative 4 times negative 3 is a positive 12. And we can do a little bit more simplifying on the right. So I'll bring down this negative 4x plus 12 again. And then on the right, we can combine the 3 and the 12. So 3 plus 12 is 15 minus 4x. And now I'll go ahead and move all the variables to the left. So I'll go ahead and add 4x to both sides. So now if you notice for this one, negative 4x plus 4x, these guys cancel out again. Same thing on the right, but we're still left with a 12 and a 15. So we don't need to put in zeros for those. So let's bring down the 12, and now 12 is equal to 15. So for this one, 12 is never equal to 15. This is not a true statement. And so that means that this one has no solution. Anytime you end up with two numbers that aren't the same, has to be no solution. Another way that you'll see this written on the homework is this symbol here. So this means the empty set. So this means that there's no numbers in our solution set. And if you want a summary of these special cases, there's a nice summary of the solution types. So whether you have one solution, an infinite number, so that's our all real numbers, or no solution, on page 138 in the book. Remember, the book is online under the eText tab on the side. All right, so these last examples are a little bit trickier. These are the ones with the fractions and the decimals. And so for clearing fractions or decimals, oops. You first want to still distribute first, get rid of those parentheses, and then we'll take a look, and then we'll go ahead and clear the fractions. And so what we're going to be doing for the fractions is we're going to multiply by the LCD. And then for decimals, this one will make a little bit more sense when we take a look at an example. But for decimals, we want to multiply by the highest decimal place. And so what I mean by that is if our largest decimal place that we have is the hundredths place, we're going to multiply every single term by 100. So let's go ahead and just look at a couple examples. These ones are going to take a little bit longer just because multiplying all the fractions can be a little lengthy if you want to do them off to the side. So let's go ahead and look at the first one here with some fractions. So we're given 1/4 x, and I'm leaving a little bit of space on the side here because we're going to be multiplying all of these by the LCD. So 1/4 x minus 4 equals 3/2 x plus 3/4 x. All right, so our LCD for this one, we wanted to get the LCD of all of the fractions. And so we have a 4, a 2, and a 4. So our LCD is 4. And so we're going to go ahead and multiply every term. And this part's important. You don't just want to multiply the fractions. We have to multiply every single term to keep our equality here. So multiply every term by the LCD. Put stars around this because this part's really important. Okay, So right now this looks kind of ugly. If I were to combine like terms, I have to deal with fractions and then more fractions when I bring it over here. And so what we do by multiplying by our LCD is we're going to get rid of all of the fractions here. So let's go ahead and take a look at the first one. We want to multiply this first term here by 4. And so you can write it as 4 over 1 or just 4. But either way, these 4s are going to cancel out. So our denominator is gone and we're left with 1 over 1, which is just 1x. And then we need to do this to every single term. So we're going to multiply this 4 by 4. We're going to multiply this 3/2 by 4 over 1. And then we're going to multiply this 3/4, put it over here, by 4 over 1. All right, so 4 times 4 is going to be 16, so minus 16. And then when we multiply these, this 3/2 by 4, I'm going to go ahead and reduce. And so if we reduce the 2 and the 4, divide them both by 2, the denominators again become 1, so those are gone. And then we're left with 2 times 3, which is 6x over 1, but we don't need that. Plus the second or last term here, these 4s again cancel out. And so we're left with 3 over 1, which is just a 3x. So that's usually the toughest part of these examples here, but once you have that done, we have a nice equation with whole numbers. So let's go ahead and try to simplify first. Left side we can't simplify. Right side we can combine our x's here. So we have x minus 16 equals 9x. Now we only have one constant term, so I'm going to leave the constant on the left and move the variables over to the right. So I'll subtract this x. So we're left with negative 16 equals 9x minus 1x is 8x. And then we'll go ahead and divide both sides by 8. And so negative 16 over 8 is negative 2 equals x. So you can always write it like this. If you want to switch it around to x equals negative 2, perfectly fine. All right, let's go ahead and try another one with fractions. This one looks a little uglier because we have to distribute first. So number 2, we're given 1/4 parentheses x plus 3 minus 2/3 parentheses x plus 1 equals negative 2. And so before we clear the fractions, we want to distribute first. Otherwise, clearing the fractions first is going to make this kind of a weird way to solve it. So let's go ahead and distribute. And so this is the only part that we have to do where we actually deal with multiplying with the fractions besides clearing with the LCD. And these ones aren't too bad. So we have 1/4 times x is just 1/4 x. 1/4 times 3, can always do this off to the side if you want, but write it as 3 over 1. So 1 times 3 is 3 over 4 times 1, which is 4. So plus 3/4. And now we want to distribute in a negative 2/3. So negative 2/3 times x is negative 2/3. And negative 2/3 x. And negative 2/3 times 1, that one's nice and easy, still negative 2/3 equals negative 2. All right, so now we have everything distributed. And before we start combining like terms here, so we don't have to add all those fractions together, let's multiply by the LCD. And so our LCD here, we have a 4 and a 3, so our LCD is 12. And so we're going to go ahead and multiply every single term here by 12, or 12 over 1. And some of these aren't going to fit all that nicely. You can always do this off to the side if you don't like trying to squeeze it in here. Some of these I will do off to the side. And then remember to multiply even the terms that don't have fractions by the 12. All right, so now let's go ahead and multiply these. So 12 over 1 times 1/4. Reduce this down, so divide both of them by 4 and we get 1 and 3. So we have, the bottoms are 1s, we don't care about those anymore. 3 times 1x, so 3x. 3/4 times 12 over 1, again reduce the 4 and the 12 to a 1 and a 3. Bottoms are 1, so we don't care about them, and we have 3 times 3, which is 9, and it's positive. This next one here, I'll go ahead and do off to the side just so we don't have a ton of fraction multiplication going on over here. But we can go ahead and reduce again. So reduce the 3 and the 12 by 3, so we get 1 and 4. The bottoms are 1, so we get 2 times 4, which is 8. And back to here, remember there's a minus sign in the front, and then we have an 8x. And then minus 2/3 times 12, it's exactly the same as what we just did, so it's 8 with that minus sign. And -2 times 12 is -24. Fractions are gone, so now let's go ahead and combine like terms on the left side. 3x minus 8x is -5x. 9 minus 8 is 1, so plus 1 equals -24. Let's go ahead and get all of our constants on the right because the variable's on the left, so we'll subtract 1. And so we get -5x equals -25. And now we can go ahead and get the x by itself, divide by -5. And so these guys cancel, and we get x equals +5. All right. Now let's go ahead and take a look at a decimal example, and I'm going to go ahead and just erase this work off to the side. And so this one is 0.06 parentheses 100 minus x plus 0.04 x equals 0.05 times 92. All right, so this one looks pretty ugly. There's a lot of decimals here. But before we can start clearing the decimals, let's go ahead and distribute. So 0.06 times 100, instead of writing this one out, anytime you multiply by a multiple of 10, you move the decimal over however many zeros you have. So multiply by 100, we're going to move this decimal over twice. So it's at the end here, so we just have a 6. But that's only for the first term, so I'll go ahead and erase that. And now 0.06 times -x is just -0.06x. Can't do anything with this guy, so plus 0.04x. And then on the right, 0.05 times 92, I'll go ahead and just multiply it off to the side down here. So 0.05 times 92. 2 times 5 is 10. 2 times 0 plus 1. And then 2 times 0. Put a 0 down there. 9 times 5 is 45. 9 times 0 plus 4 is 4, and 9 times 0 is 0. Let's add these. So we get 0, 6, 4, 0, and then we want to move it over 2 decimal places. So we end up with 4.6. And I'm just going to leave that 0 off at the end. All right, so all of our distributing is done. Our parentheses are all cleared. Now we want to go ahead and multiply by the highest decimal place. So we have no decimals here. We have 2 decimal places, so hundredths here, and only tenths here. So our largest is 2 decimal places, so we want to go ahead and multiply by 100. And we want to do the same thing. We want to multiply every single term by 100, even if it doesn't have a decimal. So let's go ahead and multiply this 6 by 100. We'll multiply this term here by 100, this 0.04x by 100, and this term on the right by 100. And so now 100 times 6 is 600, minus, again, if we multiply by 100, we move the decimal over twice. So it's now at the end of the 6 here, so it's just a 6x. Plus, same thing with our 0.04, move it over 2 places, and it's at the end, so it's just a 4x. And on the right, when we move this one over 2 places, it goes over once, twice, and so we need to add in another 0 over here, so it's 460. All right, now we have some nice whole numbers to work with. If your decimals aren't all gone, or with fractions, if they're not all gone, then you either didn't multiply by the highest decimal place, you might have multiplied by the tenths instead. And with fractions, you didn't multiply by the LCD. You might have multiplied by, like with this one, if we multiplied by a 6, it would have cleared these fractions, but not the ones with the 4s. So just keep an eye on those. It could also be that you just multiplied incorrectly, but things happen when you're doing these. All right, so back to this one. Let's go ahead and combine like terms. So we still have this 600. Negative 6 plus 4 is negative 2x equals 460. Let's move the 600 over to the right. So subtract 600. So we're left with negative 2x. These are opposites, so we want to subtract them. And so we get 140, and it has to be a negative because of that negative 600. And then let's divide both sides by negative 2. And we get x equals half of 140 is 70. And so these ones here are the ones that are going to be a little bit messier to check, just because when you plug them back in, you want to plug it into the very first equation. And so you're going to have to check with some decimals, but it's just going to be a lot of calculations off to the side when you're multiplying by the decimals. But it's still completely doable. All right, so 2 more examples here, and these ones are going to be a couple of word problems. And so for these, we're told to perform each translation. And so what that means is we're going to be given a sentence, and we want to go ahead and figure out whatever they're asking for in terms of numbers and variables. So we're told that 2 numbers have a sum of 36. One of the numbers is represented by R, write an expression for the other number. All right. So with these, I find it's easier to use actual numbers first and then see how that relates to the variables. So we know that two numbers have a sum of 36. So if I said that one number was 6, how would we find the other number knowing that they have to add up to 36? Well, what we could do is we could take 36 and subtract 6, and that would tell us what the other number is. And so the other number would be 30 in this case. And so instead of knowing that the number is 6, we know that one of the numbers is r. And so we can go ahead and do the same thing, except this time we're taking 36 and subtracting r. And so we won't know what the other number actually is because we don't know what r is, but this is our expression here for the other number. So again, using actual numbers first is a lot easier, and then just kind of plugging in your variable into that expression. Let's go ahead and try one more of these. So two numbers have a product of 18. One of the numbers is represented by x. Write an expression for the other number. All right, and so one thing to keep in mind when you see these problems in the homework, if they specify a variable, like this one used r, make sure you use r in your answer, otherwise it's going to mark it wrong. But it should give you some kind of indication that it's correct except for the variable. All right, so take a look at this one, see if you can figure out doing kind of what we did up here, and I'll go ahead and get you started. We know two numbers have a product of 18. That means multiplication. So if I said that one of the numbers was 6, and we know that it has to multiply to 18, how could I figure out what the other number is? Well, we know if they multiply to 18, to find the other number, 18 divided by 6 should give us the other number, which is 3, which makes sense because 6 times 3 is 18. And so notice we're always doing the opposite of what they give us. So up here we had the sum of 36, so we had to subtract. This one we have the product and we had to divide. It's kind of like solving an equation, you have to do the opposite. And so if we know that one number is x, then let's go ahead and replace this 6 here with an x. So we get 18 over x. All right, so then that's going to be our first kind of word problem example. And we're going to take a look at a bunch more of these in the next section.